Fundamentals of conventional vehicles and powertrains. In this chapter, we'll discuss electric vehicle configurations, electric vehicle parameters, vehicle model, resistances, tractive force, vehicle performance, braking performance and distribution, vehicle power plant and transmission characteristics. So we'll discuss the vehicle dynamics in this chapter in detail. The first point we'll discuss is the electric vehicle configuration due to energy sources. As we have seen, electric vehicle consists of various energy sources. It can have a battery, it can have supercapacitor, it can have fuel cell, it can have flywheel. So these are the four energy sources which are used for electric vehicle applications. Now these are used in combinations with each other. So based on these combinations, there are various energy sources configuration, electric vehicle configurations based on these energy sources. Also, for this configuration, power electronic converters are required, and another notation is used here is the reformer, that is for hydrogen production. It is the onboard hydrogen system for hydrogen car. So in the fuel cell configuration, reformer is also used. Now we can see the first configuration where it has a battery connected and power electronics converter and then given to the drive system. So this is a simple configuration where a battery is used and battery will supply the required energy, and based on the range of the vehicle will be decided. Now a single battery or the battery bank is used, battery stack is used, which is a supplying all the requirement, and obviously motor is connected and it will drive the vehicle. So here in every configuration, obviously battery is supplying to the motor. Now here the energy required and power required is both fulfilled by the battery. So energy density and power density is there, and based on this required power to provide the torque and speed and to maintain the range, battery will take care. Now in another configuration, two battery sources are there. So you can see this B and this battery symbol B. Now here the source is no doubt a battery, but instead of single battery there are two batteries, from which one battery will constantly supply for the energy requirement and one battery will take care of the power requirement of the vehicle. So range of the vehicle is now increased by using these two battery sources exclusively for power requirement and energy requirement. Now the next configuration is a battery combined with a fuel cell. So here two sources are there, so it is called as a hybrid combination, and in with this hybrid combination, range of the vehicle is again increased. It will provide the best combination with these two. So battery will take care of the continuous supply for long time and increasing the range, and fuel cell will also take care for supplying the energy for this. So both will work, and in combination with this power and energy requirement, these two requirements will be fulfilled by this battery and fuel cell combination. Now here slight modification is there. The onboard hydrogen production technology is connected and a reformer is there. So very similar configuration to this, only the reformer is added here for the continuous supply of the hydrogen. So here hydrogen is in the storage form, and once it is completed, we have to refill it. The next combination is a battery with a supercapacitor. So battery will take care continuously for the energy requirement, and capacitor will provide the power requirement. So in support with these two sources, the range of the vehicle will be increased, the power requirement will be fulfilled, and overall efficiency will also increase, and the vehicle range will also increase. Now the last combination is battery and flywheel. So flywheel will be used for a short duration, as like the earlier combination, it was combined with the supercapacitor, it was combined with another battery, it was combined with fuel cell. Here flywheel is used. Flywheel converts the kinetic energy, and it can be used for purpose of supporting the vehicle. It may use directly as a kinetic energy, or it can convert it into electrical energy, and it can be given to the uh, motor as a source. So these three combinations, these are the four combinations, these are used, and these are due to the energy sources. Now the another combinations can be due to the electric propulsion. How the electric propulsion is given, that will decide the vehicle configuration. So in the first combination, we can see there is a motor, also there is a clutch, and there is a gearbox, and a differential is there, and through this differential it is connected to the axle and to these wheels. So this is a, suppose this is the front side, then it is a front driven vehicle, and motor is supplying the required torque and uh, required power. Now the next combination, here we can see slightly modified. Motor is there, but the clutch and gearbox, these are not there. Now it is connected with the fixed gearing mechanism to remove this, and differential is there. So the complexity is now reduced. Now in the third configuration, further the system is made simpler. So here you can see the motor is there, fixed gearing mechanism is there on the axle, and differential is also there. So the transmission losses are reduced because it is on this, it is arranged in the same axis instead of transmitting in 90 degrees. Further, we can modify by reducing the differential also, which is supporting to transmit the power, and it is a gearing arrangement to control the smooth rotation or smooth turning of the vehicle. As they turn, the vehicle speed, wheel speed has to be adjusted properly so that the vehicle can go take a smooth turn. So for this turning purpose, the differential is taking care. But if you remove the differential, then we have to make the arrangement such that the vehicle speeds can be controlled independently. So there are now two motors, that is one motor in each wheel. So this front one wheel and this is second. So two motors are there. So relatively the simpler mechanism and differential is removed. In the next configuration, we can see whatever this transmission was there, that is also reduced. Now the motor is there, and the fixed gearing arrangement is itself into this attached to the wheel. And further improvement, the motor will be the part of the wheel itself. So there is no any linkage with the gearing. The speed of the motor will be controlled and it will directly vary the speed and torque of the vehicle. So this is how the variations in the propulsion can be made considering these designs. Here we can technical parameters of electric vehicles. So parameters will be based on the components. Type of parameters will be vehicle parameters, electric motor parameters, lithium ion or battery parameters. Mostly it is a battery parameter. Now these are the main parameters where vehicle parameters can be weight of the vehicle, curb weight of the vehicle, then gross weight of the vehicle. What is the front area? That is the one parameter, that is the frontal area. Wheel base in meters. So these are the units. Height of gravity of center in meters. Drag coefficient. So these are the vehicle parameters. Now in terms of electric motor parameters, it is the maximum speed in RPM, maximum power in kilowatt, energy capacity, maximum power in kilowatt, maximum charge, maximum voltage, number of cells per row, and number of cell rows. How many rows are there, and in rows how many cells are there? So these are the vehicle parameters.